this next video, we're going to look at algebraic expressions. Now, if you remember from the last video, we said that expressions in math are like our math sentences, and there was three different things we said that they could have. They could have numbers, variables, and operations. Those are the three different things that can make up our operations. And last video, we kind of just said that we weren't going to worry about variables. We just looked at different expressions that had numbers and operations. We used order of operations to evaluate those expressions. Now today we're going to look a little bit at algebraic expressions, which comes from the word algebra. And algebra is when we start dealing more with variables. So let's first look at what variables are. Variables, we first need to understand a little bit more about numbers. Okay? So numbers in math, you know a lot of them, are lots of different kinds. We have a whole number like 3, we have integers, we have the rational numbers like 1/3 and 0.489 repeating. Then we can have irrational numbers like pi, so numbers that go on and on and on and on and on forever without repeating a pattern. Right? So those are all examples of numbers in math. And another word for numbers in math, we can call them constants. Right? Another word for number is constants. When you think of something that's constant in life, it's something that doesn't change. And numbers are unchangeable. The number 3 is always 3. Now, of course, you could do an operation to it and change it, but that doesn't actually change the number. 3 is 3. That's it. Doesn't change. 1/3 is 1/3. It is constant. It is that number. Variables, on the other hand, are things that are changing. So obviously in life, not everything is always the same. Things are changing all the time. And we need a way in math to show that. So variables are a way of showing quantities that we don't know or could be changing. And the way we do that is we use letters to represent them. So, X, Y, Z, any letter in the alphabet, it's a variable, right? It's a letter. We use them to represent values for numbers. We also a lot of time use Greek symbols. So, theta and alpha, we use them a lot of times for angles. You'll see them a lot. They're values that we don't know yet. Right? So we use letters to represent them for now. So variables are letters. You may be thinking, why do we have to introduce things like letters into math? Why couldn't we just keep it simple and have numbers? Let me show you an example where you might have already seen a letter or a variable in math. A equals L times W. Right? A letter is equal to another letter times another letter. What does that mean? Some of you may already have seen that before. A stands for area, L you might realize stands for length, and W stands for width. And it's our formula for the area of a rectangle. Right? Rectangles' lengths and widths are always changing. Not every rectangle has the same length, and not every rectangle has the same width. They're changing values. They're not constant like our numbers. They're always changing. So we can use the letter L to represent the length of a rectangle. It could be 2 meters, it could be 9 feet, it could be 100 meters. It's always changing. It's different for every rectangle. Same with the width of a rectangle. So then, if I gave you a rectangle, I'd give you a rectangle like this one with a length of 2 centimeters and a width of 3 centimeters. You could then go, okay, in this case, L, the length is 2 centimeters, and W, the width, is 3 centimeters. And you know the values for them. But that's just for this specific rectangle. So we use letters to represent things we don't know yet, things that are changing. Take a look at some expressions now that have variables in them. The top two here are similar to expressions we would have seen in our last video. Right? They just contain our numbers and our operations. But we just said that we can put variables, we can put our letters into expressions. Now, a variable is just a number. It's a number that we don't know yet what the value is. It could be 2, could be 4, could be a half, could be 3.5. We don't know yet. So we can treat them like numbers. Anything a number can do, a variable can do. So we could add a variable. We could subtract a number in a variable. We could divide. We can square. We can multiply and subtract. We can do all of that to variables. Now, one tricky thing is here. We have 5t. This really means 5 times t. Now, why do you think we would write it just 5t instead of 5 times t? The reason we do that is because the times symbol looks like an x. And now that we're introducing variables, letters into our expressions, you can get confused between a variable x and the operation times. So whenever we write a number right beside a letter, normally we write it right in front of the letter, it is multiplication. So this means 5 times t. Same thing here, 5m really means 5 times m. I want to talk about something called substitution for a second. Here are 3 different expressions. We have t plus 4, we have 3d, we have 3d, which really means 3 times d, remember? And we have 5l, 5 times l, subtract 3 times l. Now what do we do with these things? Right? It's just a number and a letter. What can we do with them? Well, not much right now. But remember I said that variables really are numbers. They're just numbers that we don't know yet. So once I tell you what the letter is, then you can evaluate the expression like we did in our last video. For example, the first one. Let's say t equals 2. Okay? I could have picked 1, I could have picked 0, I could have picked negative 5, could have picked anything. But let's say, just for fun, that t equals 2. What we can do now is we can substitute 2 in for t, because we know what the value of t is now. T is 2. So instead of t plus 4, we can write this is 2 plus 4, which is 6. Right? If I picked a different value for t, we would have got a different answer when we evaluated the expression. Right? Let's do this one. Let's say, for fun, that d equals 5. So this would mean 3 and d is 5. So really this means 3 times 5. And I wrote this like brackets. It's another way we'll see multiplication written. Whenever we have something written side by side in brackets, it means multiplication. So this would equal 15. So 3d is equal to 15 when d is 5. Let's look at the last one. Let's say L is 4. That means I can substitute 4 in anywhere I see an L in my expression. So this L here is equal to 4. Subtract 3. This L as well is equal to 4. So 5 times 4 is 20. Subtract 3 times 4 is 12. So this would evaluate to 8. Alright, I hope you've had a chance to try evaluating these expressions. Well, let's take them up. So the first expression, we have 5 times t minus 2 divided by 9. And I've told you that t equals 4. Remember, if we didn't know, or we didn't tell you what t was as a number, you wouldn't be able to evaluate it. But now we know we can substitute 4 into t, because that's what t is. So this becomes 5 times 4, because t is 4, so 4 replaces t, it substitutes in, minus 2 divided by 9. And at this point, we just use order of operations like we did in our last video. So we can multiply, it becomes 20 minus 2 divided by 9. Remember, when we have a fraction, we simplify the top and simplify the bottom. So this becomes 18 over 9, and 18 over 9, 18 divided by 9 is this expression, when t equals 4, is 2. Let's take a look at this one now. So we have 3 minus q squared plus 1, and I'm telling that q is 0. So we can substitute 0 in for q. So I replaced q with 0. Now we just do order of operations. Brackets first, 3 minus 0 is 3. Next we do our exponents. 3 squared, remember, it doesn't mean 3 times 2. It means 3 times itself 2 times, so 3 times 3 is 9. 9 plus 1, and it equals to 10.